What is a ratio? Well, a ratio is a comparison of two or more quantities that are related. So here we have two different quantities or two different shapes. We have circles and we have squares, and we could actually write a ratio based on this picture. So the ratio of circles to squares is 2 to 3. There are 2 circles for every 3 squares. Now that's just one ratio we could write based on that picture. We'll come back to this in just a minute. So here's another ratio based on a picture that you could write. The ratio of boys to girls is 1 to 4. There's 1 boy for every 4 girls. And there are 3 different ways that you can represent or write a ratio. We can use a semicolon. We can say 1 to 4, use the word 2. We can also write it as a fraction. Ratios can be represented as fractions. So all of these mean 1 to 4. The ratio of boys to girls is 1 to 4. Now there are 3 different types of ratios. There are part-to-part ratios, part-to-total ratios, and rates. In this video, we're going to focus on the first 2 types of ratios, part-to-part and part-to-total. So let's look at this example here. Let's compare and write a ratio of girls to boys. Well, we have 5 girls and we have 2 boys. So the ratio is 5 to 2, and we could write that 3 different ways. Now, is that a part-to-part or is that a part-to-total? Well, girls is just a part of the class and boys is just a part of the class. You're comparing one part to another part. That's a part-to-part ratio. Okay, let's do the next one. So a ratio of boys to girls. There are 2 boys for every 5 girls. So the ratio is 2 to 5. And again, this would be part to part because you're comparing part of the class to another part of the class. Let's look at our last example. The ratio of girls to students. Well, there are 5 girls and total students there are 7. And we can write that 3 different ways, 5 to 7. Now is that part to part or is that part to total? Well, we're comparing the girls, which is a part, to the total number of students in the class. So that's a part to total ratio. So let's practice writing some part to part and part to total ratios. Now here's this example that we just looked at a moment ago of the 2 circles to 3 squares. You can write 2 ratios, 2 part to part ratios based on this picture. We could compare circles to squares. So there are 2 circles and 3 squares, or we could reverse that. We could compare the squares to circles. Now those are both part to part because we're comparing circles to squares. One part we're comparing to another part, or squares to circles. It's one part and we're comparing it to another part. Now we're going to write 4 part to total ratios. So the ratio of circles to shapes. And maybe I'll even say all shapes. Circles to all shapes. So circles, there are 2. To all shapes, there are 5 total shapes. We could also do squares to all shapes. So that would be 3 to 5. So we're comparing a part to the total number, a part to total ratio. And for our last 2 part to total ratios, we could compare all shapes to circles. So that's 5 to 2, or we could do all shapes to squares. And that would be 5 to 3. So those are 6 different ratios that we could write based on that situation. And actually we could probably, if we looked at colors instead of shapes, we could do another 6. We could do yellow to blue, blue to yellow. We could do yellow to all colors. And again, this is just a reminder of the 3 different ways that you can represent a ratio. Okay, so we're going to clone these shapes to show a ratio of 2 to 1, stars to circles. That means for every 2 stars, there is 1 circle. That's a ratio of 2 to 1, stars to circles. Now that's only one possible solution. There's actually an infinite amount of solutions for this, because another way I could represent 2 to 1, that's a 2 to 1 ratio. I have 4 stars for every 2 circles. Well, that simplifies to 2 to 1. I could also do 6 to 3. That's a ratio of 2 to 1. I could even do, I'll do one more here, I could do 8 to 4. All of these are equivalent ratios. If I simplified these 3 ratios, they would all simplify to 2 to 1. So when asked to do a representation of 2 to 1, these would all be correct. So we just made some equivalent ratios. Let's make a few more. So here we have a ratio of 1 to 4, and I'm going to write that as a fraction, 1 to 4. So if you were asked to write some equivalent ratios, a real easy way to do it, if I just double the numerator and denominator, 2 to 8 would be an equivalent ratio. I could double them again, 4 to 16. I could double them again, 8 to 32. All of these ratios, if you simplified them, they all would equal 1 to 4. We could use that same technique if you were asked to write equivalent ratios for 3 to 5. I could double each one of these, and I would end up with 6 over 10. I could double it again, double the numerator and denominator again. All of those ratios are equivalent. They're all equal. They would all simplify to 3 to 5. And we'll just do one more. If the ratio was 3 to 2 and you wanted to write some equivalent ratios, just double them. So it'd be 6 to 4, 12 to 8, 24 to 16. Those would all be equivalent ratios. So that's what a ratio is, and that's how you can work with them.